Okay, now we've gotten the simple alkanes out of the way, and we've named a few substituents. Now we can start using all this information in order to name larger and more complex molecules. So we're going to go over the nomenclature for alkanes, and we're going to use the International Union for Pure and Applied Chemistry. They've defined this, so it's a well-defined system for naming alkanes. And so we're going to start with an example. So I'm going to draw out a structure, and we are going to come up with a name for this molecule here. So the first thing we need to do is we need to look for the longest continuous carbon chain in this molecule. Okay, so in this molecule, we can count our carbons in a number of different ways. Let's start on the left side. We can go 1, 2, 3, 4, 5, 6, 7. So here we have 7 carbons in a row. And let's see if there's any other ways we can count this out and get a larger carbon count. So we start at this carbon here. We can go 1, 2, 3, 4, 5, 6. It's not longer than 7. We can start here, 1, 2, 3, 4, 5. So not any longer. So 7 here is going to be the largest continuous carbon chain. So that's going to be our parent structure. So our parent structure is going to be a derivative of heptane. So heptane is 7 carbons. So that's going to be our parent structure. Okay. So now we need to look at our structure here, and we need to find, well, what didn't we name as part of that heptane? So what is left over? So 1, 2, 3, 4, 5, 6, 7. What is left over? Well, we have 1 carbon at this position, and we have 1 carbon at this position. So we have 2 methyl groups present. So our second task is to identify the substituents. You might call them substituents or subchains. It doesn't matter which. Okay. So here we have 2 different methyl groups. So now we need to name. We have these substituents. So when we put this into our chemical structure name, we are going to put our substituents in alphabetical order generally. And if we have more than one of the same thing, we're going to use a prefix. So since we have 2 methyl groups here, we would say it's a dimethyl heptane molecule. If we have 3 methyl groups, we would say a trimethyl heptane molecule. So here it's going to be dimethyl heptane. All right. So our dimethyl here, that's going to be our substituent. Okay. The last thing we need to do is to give the position of where our substituents are. We can put methyl groups at various positions in this molecule, and each of those would be different. So we need to give sort of a chemical address for where these methyls reside. So we need to find the position for our substituents. And we want to do so and obtain the lowest numbers possible when we find our numbering. Okay, so in this case, we're going to look at our heptane molecule, and we're going to number our carbons. So we're going to start from the left side. Doesn't matter left or right in this case, but we're going to start with the left for this example. We're going to number these 1, 2, 3, 4, 5, 6, 7. Okay, So in this case, our methyl groups are at the 3 and 4 positions in our molecule. Right? So we would happen to number it from right to left, and I'll do so in pink. It will be 1, 2, 3, 4, 5, 6, 7. So in this case, we have a 4,5 dimethylheptane, right? So 3,4 is going to win out over 4,5. So when we go to our naming, we're going to use 3, 4 dash, this is our positional address of where our substituents are. So it's a 3,4 dimethylheptane. Right. So in any name, we have the position, we have the substituent, and we have the parent. Okay? So you should be able to take any structure and be able to convert that into a name. Really, we do this just so we're able to communicate clearly about what molecules we're actually talking about in class. You should also be able to take the name and convert it into a structure. So as an example of that, let's draw out a name, and we'll work backwards, and we'll take the name and convert it into the structure. So here, the name I'm going to use is 3-isopropyl hexane. Okay? So here, we can separate this into the parent, the substituent, and the position. So here, at the end, always at the end, we're going to find our parent. So our parent structure is going to be hexane. So we can go ahead and start to draw that out. 6 carbons in a row. 1, 2, 3, 4, 5, 6. Okay? Next, we have our substituent. Our substituent is the isopropyl group, and it's going to be at the 3 position. Okay? So here, if we number our carbons in this chain, we have 1, 2, 3, 4, 5, 6. And if we add an isopropyl group at the 3 position, 1, 2, 3, we'll add a 3-carbon substituent, and it's an isopropyl substituent, so we know it's going to be branched. Right? So here we have converted our name into our final structure. It's a hexane derivative. 1, 2, 3, 4, 5, 6 is your longest continuous carbon chain. We have a isopropyl substituent right here, and it's at the 3 position. So again, you should be able to convert structure into name or name into structure.